This is Geometry, section 7.3, Proving Triangles Similar. So this section is going to look a lot like what we did first semester when we proved triangles were congruent. So we had things like side, angle, side, angle, side, side, etc. So we're going to use things that are similar to those to prove that triangles are not congruent, but similar. So the first one is called angle similarity. So when we talked about proving triangles are congruent, we talked about how angle was not something that we could use like side was. So this one did not work. The reason is because this actually works to prove the triangles are similar, not congruent. But we don't call it angle. We only call it angle because if two of the angles are the same, then the third one has to be the same by default because we know that the three angles of a triangle have to add up to 180. So this postulate says if two angles of one triangle are congruent to two angles of a second triangle, then the two triangles are similar. And remember, just the plain squiggle with no equal sign under it means similar, not congruent. So, for example, show the triangles are similar and write a similarity statement, meaning match up the three letters of the triangles. So, right here, in these two triangles, we need to prove that two pairs of angles are congruent. So to start off, angle 1 and 2 are congruent because they are vertical angles. Notice that these two sides, the top and the bottom, are parallel to each other. That means I can say angle S is congruent to angle R because these are parallel lines. This is a transversal, and these are alternate interior angles. So angle S is the same as angle R because they are alternate interior angles. We could say the same for U and E, but since the postulate above says I only need two pairs, we've got that already. We're done. So triangle SUP, we need to be careful here. S matches up with R, not E, because S and R are the same since these are alternate interior angles. So we're going to start with R, and then U would match up with E, and then the leftover is P, because of the angle similarity postulate that we just talked about up above. So this one, angle E is congruent to angle N because that's really just given to us. It tells us that each of them are 40 degrees, so obviously they're congruent to each other. Notice that we have these two sides are congruent to each other and these two sides are congruent to each other. So if I wanted to find angles 1, 2, 3, and 4, we could use the fact that these are isosceles triangles, subtract 40 from 180. The leftover is 140, and then since these are isosceles, we know 1 and 2 are the same as each other, 3 and 4 are the same as each other. So I just take that leftover and divide it by 2. So each of these is 70. So if we look at that, we've got three angles of this triangle are the same as three angles of this triangle. We really only need to say two pairs of them, so we could just pick 1 and 3. So 1 is congruent to 3 because we figured that out using isosceles triangles. Therefore, EPL would match up with NLA. And again, that's the angle similarity postulate. We matched up two pairs of congruent angles, making those two triangles similar to each other. Side similarity postulate. We need to be careful with this one. First of all, when we're naming it, we need to make sure we put that squiggle at the end to show that we're talking about side similarity and not side for congruent triangles. So this one is different because in side for congruence, we needed to show that all three pairs of sides were congruent to each other. For similar triangles, we know that that's not going to happen. All of the corresponding sides, so the lengths of the corresponding sides, in order for them to be similar, two triangles need to be proportional to each other, not congruent. So if all pairs of sides are proportional, then the triangles are similar. So in other words, kind of like we talked about in the last section, the proportion of, or the ratio of A to X needs to be the same as B to Y and C to Z. So determine whether these triangles are similar and explain why. So if we look at these two triangles, let's write the ratio of the shortest sides of these triangles. So the shortest side in the smaller one is 6, and this one it's 10. So 6 to 10 would reduce to 3 to 5. Medium side, so the next one in this triangle is 25, next one in this triangle is 15. 15 compared to 25 also reduces 3 to 5. So if this ratio is the same, 3 to 5, then we know that these two triangles are similar. So this side is the last one, this is the last one. 18 to 30, both of those can divide by 6. Whoops. So when I divide by 6, I get 3 to 5. So the ratio of all of the sides is the same, therefore the sides are all proportional. And triangle BRT is similar. Remember, don't write congruent, just write the one squiggle for similar. So B matches up with, this is tricky here. This is the smallest side. This is the medium side, and largest side. I really shouldn't have put tick marks on there. I should have put squiggles since they're not technically congruent. So we'll put squiggle marks on there. Okay, so the B is in between the 1 and the 3. So we need to look for which one is in between 1 and 3. Well, it's right here, A, so that matches up with A. And then R would match up with the one in between 1 and 2. 1 and 2 is right here, P, and then the leftover is U. All right, same thing, determine whether the triangles are similar and explain. So let's start with the small sides. We've got 4 and 6. So 4 to 6 reduces to 2 to 3. And then the next ones, we've got 10 and 15. 10 over 15, those divide by 5, that also reduces to 2 to 3. And then we've got 12.5 and 18. This one you're going to have to type into your calculator probably to figure out what the ratio is. If you type it in, you do not get 2 over 3. So that is not equal to 2 over 3. We really don't care what it is. We just care that it's not the same as these other two. So if it's not the same as those other two, this is not similar to the other triangle. We'll call it, let's see, BRT. ILS is the other triangle. It really doesn't matter what order we name it in since it's not similar anyway, because not all sides are proportional. Okay, so the last postulate, we've done angle-angle, we've done side-side-side similarity, now we have side-angle-side similarity. So for this one, if you have one pair of corresponding angles, from two triangles are congruent to each other. So remember, in similar triangles, the angles still have to be congruent, even though the sides aren't. So for example, we would have angle H congruent to angle K in this diagram. And the lengths of the sides making the angle. So the two sides on either side of this angle are A and C. Two sides on either side of this angle are X and Z. So it has to be the two sides touching that angle, just like for side angle side when we talked about congruent. It has to be two sides and the angle in the middle of those two sides. So the lengths of the sides making the angle are proportional. Again, not congruent, proportional. Then the triangles are similar. So, for example, using this diagram, if angle H is the same as angle K, and A over X equals C over Z, these are proportional to each other, then we have similar triangles. So, using that, show that these triangles are similar and find the value of the variables. So we want to look for an angle and then the two sides on either side of that angle. So this is the only angle we have in this triangle. We don't have anything in this triangle, but we do know that these three angles have to add up to 180 because they make a straight line. So if I add up 34 and 112, that's going to give me 146. And if I subtract that from 180, I'm left with 34. So this angle right here is also 34, which makes angle, let's see, ROH the same as angle EOM. Okay, so we've got our congruent angles. Now we need to compare the sides on either side of those angles. So 18 on this triangle would compare to 12 on this triangle. So 18 over 12. That reduces to 3 over 2. And the other two sides, 15 compares to 10. 15 and 10 also reduces to 3 over 2. So triangle RHO, if I go this way, RHO, that would compare and be similar to triangle EMO by the side angle side similarity postulate like we just talked about. So we've got the one pair of congruent angles, and then the two sides on either side of that angle are proportional to each other. They have the same ratio. So now we need to solve for A, which is this missing side over here. Well, we've got our scale factor, these two triangles. We know that it's 3 to 2. So we're going to compare 3 to 2 to A, and its corresponding side over here, 6.6. So we just write a proportion, and then we cross multiply to solve it. When we cross multiply to solve this, we're going to end up with 9.9. All right, this one's a little bit trickier. So we've got this small triangle right here, and then the entire big triangle. So the first question is, where is the congruent angle here? Well, this angle up at the top is part of both triangles. So really, we're just using the reflexive property here to say that angle M is congruent to itself, because it's part of this small triangle, and it's also part of this big triangle. So that's our congruent angle, which means we're going to have to compare these sides and these sides. For the small triangle, the sides are 8 and 10. So we'll put the 8 here and the 10 here, and then we'll figure out the big sides. For the big sides, this is where it becomes tricky. I'm not going to compare it to 24 because that's not the whole side. That's only this piece. So in order to figure out this whole side, I need to add 8 and 24, which is 32. Same thing over here. I'm not going to compare it to 30 because that's not the entire side of the big triangle. I need to add 10 and 30, which gives me 40, and then compare those. So 8 is going to compare to 32. 10 is going to compare to 40. When we reduce both of those, so 8 goes into 32, so this is going to reduce to 1 over 4, and same thing, 10 goes into 40, this is also going to reduce to 1 over 4. So the ratio is still the same, the sides are proportional, which means triangle AME, if we start here and go up to the top and then down, means we have to start at R, go up to the top, and go down. So RMG. Again, this is the side angle side similarity postulate. The angle in the middle, the two sides that make up the angle. And to solve for B, so our scale factor we know is 1 to 4. So 1 to 4 needs to compare to B on the smaller triangle and 28 on the bigger triangle, the bottom and the bottom. So B and 28, and when we cross multiply this, we get that B is 7. If we think about it, 7 over 28 reduces to 1 to 4.